Today we're continuing on with our parent functions, and we're going to be talking just a little bit about symmetries, asymptotes, domain, and range. Okay, for the first problem, I'm not going to do anything with the symmetries. I will do something with it on the next two problems, but the majority of the lesson I won't do anything with it. So, asymptotes. This is something that you probably heard the word in Algebra 1, but it's been a while since you've taken that class. An asymptote is a line that you can't touch or cross. So when I was going through these the other day, I talked about the rational parent function, not being able to have the graph touch the y-axis, and the graph's not allowed to touch the x-axis. Those are asymptotes. When the graph is restricted from touching or crossing a line, then that is an asymptote. Okay? Most of the graphs don't have any asymptotes. This graph doesn't have any. It doesn't have any restrictions. It isn't prevented from touching anything or crossing anything. So for asymptotes, I'm going to put none on this. Domain and range, these are words that you have heard before. So to remind you, domain are your x's, and range are your y's. So for domain, since domain are x's, we're looking left and right because the x-axis runs left and right. Now, first of all, you should know that there are arrows on this linear parent function. So I'm going to move my marker left and right. As I go to the left, I hit an arrow, which means I go forever left. As I move my marker to the right, I hit an arrow, which means I go forever right. If you ever go forever left and forever right, that's called all real numbers. Because when you go forever left, you're going to hit all the negatives, and when you go forever right, you're going to hit all the positives. And there is a symbol I want you to know for all real numbers. So it's two straight up and down lines, and then you make an R. So it's supposed to look like an A for all and an R for real. So all real numbers. And I imagine you've seen that in your past. Okay, range. Range are asking us for our y's. So I'm going to be looking up and down because the y-axis is up and down. Okay, as I move my marker down, I hit an arrow, which means I go forever down. As I move my marker up, I hit an arrow, which means I go forever up. So if you ever go forever down and forever up, that is also called all real numbers. And I'm going to use the symbol once again. So two straight up and down lines, and then make an R. So now you can see the A for all and the R for real, all real numbers. Okay, if a graph doesn't have arrows, then the domain and range will look quite differently. But as long as there's arrows and the graph goes forever left and forever right, the domain will be all reals. And if the graph goes forever down and forever up, the range will be all reals. Okay, so this is our linear parent function. Now, let's move on to our absolute value parent function. Remember V in value for the V-shaped graph? So this is our absolute value parent. Okay, I do want to talk about symmetries on this one. So this graph reflects over the y-axis. If you flip this over the y-axis, this point, boop, that's where it lands. If you flip this point over the y-axis, boop, that's where it lands. So the symmetries for this one, it reflects over y-axis. And I think that's easy for you to see and easy for you to understand, so that's why I decided to talk about it. So this point is the same distance from the y-axis as this point is. This point is the same distance from the y-axis as this point is. So that's why it reflects over the y-axis. Okay, this graph has no asymptotes. There's no line that the graph can't touch or cross. There are arrows on this graph as well. They just weren't in the picture. So remember, domain are x's. So I'm looking left and right like the x-axis runs left and right. So as I move my marker to the left, I see an arrow, so I go forever left. As I move my marker to the right, I see an arrow, so forever right. So if you ever go forever left and forever right, remember that's called all real numbers. and I'm just going to do the symbol. Okay, range, these are your y's, and the y-axis is up and down, so I'm going to look up and down this time. So when I go this way, I'm going up, and the arrow means I'll go forever up. When I go this way, I'm also going up, which means I go forever up on this side too. The problem is I don't go forever down. You never see any of the graph down here. This is the lowest the graph goes. So we need to know the y value at that lowest spot. And who's that y value there? 0. So the y starts off equaling a 0. And when you go up, up, up on this side and up, up, up on this side, your y's get greater. Anytime you move up, y's get bigger and bigger. And this is the range for your absolute value parent function. Okay, let's talk about our quadratic parent function. Okay, symmetries, this is just like the last one. This point flips over the y-axis and lands there. This point flips over the y-axis and lands there. So this also reflects over y-axis. Okay, as far as asymptotes are concerned, there are none. Okay, domain. Remember, we're looking for x's. We're looking left and right. Does it look like this graph goes forever to the left and forever to the right? It does. So the domain is all real numbers. Now range, these are y's. Let's look up and down. So when I go this way, I'm going up and the arrow is forever up. When I go this way, I'm going up and the arrow is forever up. So the graph goes forever up. The problem is it doesn't go forever down. There's none of the graph down here. So who is our lowest y? Our y value right here is 0. So the y equals a 0. And when you go up, up, up on this side and up, up, up on this side, your y's get greater. So you'll notice the quadratic parent and the absolute value parent, their domain and range are exactly the same as one another. And that's essentially because the graphs look very, very similar. It's just this one's a V and this one's a U. Okay, let's keep trying. All right, so next we have our square root parent. And I'm not going to worry about symmetries on any of the other problems. Okay, asymptotes. There are no asymptotes on this. We'll get to some in a minute, but there's none for right now. Okay, domain. Remember, we're looking at x's. We're looking left and right. So when I go this way, I'm going right, and that arrow means I go forever right. But does it look like we go forever left? No, this is the farthest left x there is. Who's your x right here? Our x is a 0. So my x starts off equaling a 0, and then when you go to the right, what happens to x's when you go to the right? X's get greater. Okay, now let's look at range. Range are y's, so now we're looking up and down. When I go this way, I'm going up, and that arrow means I go forever up. But do we go forever down? No, this is the lowest y there is. And who is your y right there? Our y is a 0. And then when you go up, 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 y's get greater. So your domain is x is greater than or equal to 0, and your range is y is greater than or equal to 0. Okay. The cubic function, I'm going to let you try to see if you can figure out the domain and range for yourself on that. I will tell you right now that there are no asymptotes, and we're not going to do anything with symmetries. Okay, let's go down to the cube root one. Okay, so once again, we're not going to mess with symmetries, and there are no asymptotes on this. So now let's talk about domain. Any ideas what those x's are doing? They are going forever to the left, and they're going forever to the right. So the domain is all real numbers. Okay, and what about the range? What about those y's? What do you think? This graph is going to go forever down, and it's going to go forever up. Now, it's going forever down very slowly. I mean, you are getting smaller and smaller and smaller and smaller and smaller, but it's very gradual. And here you're going farther up and up and up and up, but it's very gradual. So it's going to take you a really long time before you get into high Y values or low Y values, but you do keep going up and up, and you do keep going down and down and down. So the range is all real numbers. Okay, let's look at the next three. All right, so rational. This is the one where I told you that there are things that the graph can't do. The graph is not allowed to touch this y-axis, and this graph is not allowed to touch the x-axis. So that means we finally have what we call asymptotes. All right, so I'm going to get rid of symmetries. All right, so first of all, do you remember Hoy and Vux from maybe Algebra 1? This is a vertical line, so this is called Vux. This is a horizontal line, so this is called Hoy. So because this is Vux, it's going to be an x equals line, so it's x equals, and what's your x value everywhere on this line? Your x is 0 because you're not right or left. Okay, this one, because it's a horizontal line and it's Hoy, it's going to be y equals. So it's going to be y equals, and who's your y value everywhere on this line? Your y is a 0. Those are your asymptotes. X equals 0 and y equals 0. Okay, so an asymptote is like an electric fence. This graph is not allowed to touch the y-axis or cross it, and it's not allowed to touch the x-axis or cross it. So when you have asymptotes, that does some restrictions on your domain and range. Okay, now remember, domain, you're looking left and right. So when you're going this way, you're going left, and that arrow means you'll go forever to the left. And when you go this way, you're going right, and that arrow means you go forever to the right. So it kind of looks like we go forever left and forever right. The problem is we're never allowed to have an x value of 0 because we couldn't ever touch the y-axis. So domain is every single number out there except the x value of 0. We say x cannot equal 0. Okay, range, these are our y's. So now we're looking up and down. So when I go down this way, I see an arrow, so it goes forever down. And when I go up this way, it has an arrow, so it goes forever up. So it looks like it goes forever down and forever up. The problem is it was never allowed to have a y value of 0. So the range is all your numbers out there except y cannot equal 0. So one way I could say this is all real numbers except y equals 0. And this one I could say all real numbers except x equals 0. But it's just easier to write x can't be 0 and y can't be 0, which means it can be everything else out there. So if you can remember what your asymptotes are, well, the domain and range just kind of go hand in hand with them, except domain, the x can't be 0, and the range, the y can't be 0. Okay, let's look at the exponential function. So first of all, I'm going to get rid of symmetries. I'm not going to worry about that. Okay, this one does have an asymptote, and it is the x-axis. This graph is never allowed to touch the x-axis. Okay, so since this is a horizontal line, this is a Hoy. And every time you have a Hoy, the letter you use for the equation is y equals, and what did we say our y value is everywhere on this line? 0. That's our one and only asymptote for this graph. Y equals 0. Okay, domain. Let's look at x's. We're looking left and right. So as I move my marker to the left, I hit an arrow, which means I go forever to the left. As I go to the right, I hit an arrow, which means I go forever to the right. So this graph goes forever to the left and forever to the right. So domain are all real numbers. If I would have had an asymptote at of x equals something, then there would have been a restriction on the x. But because there's no asymptote where x equals something, then there's no restriction on the domain. It does go forever to the left and forever to the right. Okay, now range, these are your y's, so now we're looking up and down. Okay, as I go this way, I go up, and I do go forever up. As I go this way, I am going down and down and down and down and down. The problem is I'm never going to go forever down because of this asymptote. It restricts me from touching it or crossing it. See how there's no graph down here? So the lowest we're going to get is right where that y is a 0. But because of the asymptote, it's not allowed to equal it like it was on those other graphs. So it's going to get really, really close to the y being a 0, but it's not allowed to touch it. So that's why there's no equal sign. So when you go this way, you're going up and up and up and up and up. So y's get greater. So your range is y is greater than 0. Okay, and these are just some things that you're probably just going to have to study. Okay, the logarithmic graph. This was one that I asked you guys to do for yourself the other day, but I'm going to go ahead and just try to plot some points here so we can talk about this graph. So these are points that hopefully, oops, I plotted the point wrong. It should be right here. Hopefully these are some points that you guys plotted the other day when you did this for yourself. Okay, so I'm just trying to show you kind of what this graph does. Okay, this graph does have an asymptote, and it's the y-axis. This graph is never, ever allowed to touch the y-axis. Okay, so we're not going to worry about symmetries. Now let's do the asymptote. This is a vertical line, so this is a vux. So we're going to use the letter x, so it's going to be x equals. And who's your x value everywhere on this line? Your x is 0. So that's your asymptote, x equals 0. Now that means that the x will never be a 0 value, so that means there's going to be a restriction on the domain since there is an asymptote with the x value being something. Okay, so when you go to do domain, remember we're looking at x's left and right. So when I go this way, I'm going right, and that arrow means I go forever right. When I go this way, I'm going left. The problem is I will not go forever left because of this asymptote. So it's not allowed to touch it or cross it, so the graph will never get over here on this side to keep going forever left. Okay, so the x is getting really, really close to being a 0 right here, but it's not allowed to equal the 0 because of the asymptote. And when you go this way, you go right and right and right and right and right, so x's get greater. Okay, and then range. These are your y's, so we're looking up and down. Now, because there's no asymptote on the y-axis or y equals anything, I'm sorry, not the y-axis, on a y equals equation, then there's probably no restrictions. So let's just look. So when I go down, I see an arrow, so it goes forever down. And when I go up, I see an arrow, so it goes forever up. So the range is all real numbers. Now, these three parent functions are really tricky. So if it were me, I would just have to study them, okay? So asymptotes, just to repeat that, they are lines that the graph comes close to touching, but it's not allowed to touch or cross. So the rational one had two of them, the x equals 0 and the y equals 0. And so that's why we had restrictions on the domain and range at those spots, because otherwise they do look like they go forever left and forever right and forever down and forever up. Okay, the exponential, it had an asymptote right here on the x-axis, which is the equation y equals 0. So that's why the range had a restriction where it couldn't be the 0. But because it went up, 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 y greater. And then the logarithmic, it has an asymptote on the y-axis, which is the equation x equals 0. That's why the domains had a restriction. The domain was not allowed to have that x value of 0, but the range was okay. It went forever down and forever up. Okay, so far, you've seen everything except the cubic. So I am asking you to try to figure out the domain and range on the cubic function, which is a function that you were supposed to have graphed the other day for yourself. So see if you can figure out domain and range. Okay, but I'm not done with this lesson. We need to look at problems that don't have arrows. Okay, so this is the other thing that I attached to your Google Calendar. Okay, so graphs that don't have arrows, they look quite different when you write domain and range. Okay, so domain, I'm still looking at x's, I'm still looking left and right, but there's no arrow on the left and there's no arrow on the right. That means there's a farthest left and a farthest right. Okay, so my farthest left x is right here at -5. And my farthest right x is here at 0. And I've got all the x's in between. Okay, I'm going to tell you how to figure out these signs, and then we're just going to memorize them. When I'm here at -5 and I start going to the right, the x's are getting bigger than -5. So I have to put the big mouth facing the x so it says the x's are getting bigger than -5. When I'm here at the 0 and I go left, x's are getting smaller. So I need to put the pointed end facing the x so it says x's are getting smaller than 0. In your past, you learned that closed circles get equal signs, but open circles do not. And that's your domain. So one thing I want you to know, the smallest number is always on the left, the biggest number is always on the right, and the signs will always go like this. Okay, range. These are our y's. Now we're looking up and down. Now there's no arrows, so there is a lowest y and a highest y. So the lowest y is down here at -5, and the highest y is up here at a +5. And it's all the y's in between. Okay, just to practice the signs. When I'm down here at the lowest y, -5, and I go up, 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 the y's are getting bigger than -5. So I put the big mouth facing the y, so it says y's are getting bigger than -5. When I'm here at the 0 and I go down, my y's are getting smaller. Or I'm sorry, when I'm up here at the 5 and I go down, the y's are getting smaller. So I put the pointed end facing the y, so it says y's are getting smaller than 5. And then remember, closed circles get equal signs, but open circles do not. And so, once again, smallest number on the left, biggest number on the right, and the signs always go like this. Okay, let's just keep trying. All right, this one, domain. Because there's no arrows, there is a farthest left x and a farthest right x. This is the farthest left the graph goes. This is the farthest right the graph goes. So the farthest left x value is -4, and the farthest right x value is +1. And it's all the x's in between. Now, let's just slap down those signs. Now, they're both open circles, so nobody gets an equals. Okay, let's try range. We're looking up and down. How low can you go? How high can you fly? So our lowest y is down here at -2. And our highest y is up here at 1. And it's all the y's in between. And then let's slap those signs down. And once again, they're open circles, so there's no equal signs. Do you remember doing this in your past? Okay, let's try number 3 here. All right, so domain, we're looking at x's. How far left, how far right? So this is our farthest left, and our x value here is what? -1. And then this is the farthest right the graph goes, and who's our x value at this spot? Our x value is a 5, and it's all the x's in between. Let's slap down our signs. Who's going to get the equals? The 5 is going to get the equals because the 5 has the closed circle. Okay, let's do range. Range are your y's. We're looking up and down. So how low can you go? How high can you fly? This is our lowest y. Who is the y value right here? This gets people sometimes. Who is the y value everywhere right here at this lowest spot? The y value is 0. because you're not up or down off of that x-axis. And this is the highest the graph goes, and who's your y value up here? 4. And it's all the y's in between. Okay, let's slap those signs down. Pew, pew. And who is going to get the equals? Down here at the y value of 0 is going to get the equals because it was a closed circle. How are you feeling about this? You think it's easy? Okay, looking at number 4. So domain are x's. We're looking left and right. This is my farthest left x, and this is my farthest right x. Who is the farthest left x? -1 is the farthest left x. Okay, who's the farthest right x? +3 is the farthest right x. And all the x's in between. Slap your signs down. Now, do you notice they both are closed circles? So they'll both get an equal sign. Okay, range. We're looking at y's up and down. Lowest, highest. This is our lowest y. This is our highest y. Who is our lowest y? -4. Okay, and who's our highest y? +4. And it's all the y's in between. Let's slap those signs down. And what do you need to tell me? They both get equal signs because they both had closed circles. Okay, very good. Okay, and then let's go to the next page. All right, I want to try a different one. Let's look at number 6. Now, this one, domain and range, is going to look completely different than the last 4 because these points aren't connected. So it's not every x value between here and here. It's only this x, this x, this x, this x, and this x. Okay, so this time I'm listing out a set of numbers. So my x value right here is -3, and I'm going from left to right. My x right here is -2. My x right here is +1. My x right here is +2. And my x right here is +5. And I'm going to put set symbols around these numbers. I don't draw them very well, but there it is. And notice it goes smallest number to highest number. So it doesn't look like these because these represent every single number between here and here. Because there's a point here and 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 here. And there's no way you could list all the x's between here and here. So that's why we write it in this notation, because it includes every single number you can think of between there and there. But with these not being connected with a line, then there's only this x value, this x value, this x value, this one, and this one. This is called a discrete graph, and this one is called continuous. Okay, let's look at range. Range are your y's. Now we're looking up and down, and I'm going to start with lowest to highest. So down here, this is my lowest y, and who is this y value? -5. Okay, my next lowest is right here, and the y value right there is 0 because you're not up or down off the x-axis. And then who's your y value here and here? Your y value is a 1. Now, I don't write it twice, I only write it once. So your y value is a 1 here, and your y value is a 1 here, but you only write it one time. And then who's the highest y we have? 4. And I'm going to put set symbols around that. Okay. And that's how you do domain and range of a discrete graph. All right, so what I want you to try for me is on this page, I want you to try number 5. I want you to try number 7. And I want you to try number 8. So there's 3 problems from this document. And then don't forget, I'm also asking you on the parent functions to see if you can figure out the domain and the range of your cubic parent function. Okay, so that's what I would like you to try for me, and we'll see how you do with those next time I talk to you. That's all for today. Smiley face.